What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to look at the volume of prisms, and this is actually the introduction to volume as a topic. So make sure that we're on top of this and we can do the rest of it incredibly easily. So we do need to know that volume is the total amount of space that an object occupies. So this is different to the length and area that we've talked about before, because now we want to know how much space in 3 dimensions does this thing take up. It is a really similar concept to capacity, which is how much does this thing hold, usually when we're talking about liquid. So they are very similar, but there are differences, and we're going to go into that in the next video. So make sure you know that these two things are related, but not exactly the same. So like I said in the intro, volume is a 3-dimensional measurement, and that means our units are going to be cubed. So we're going to have things like centimeters cubed and meters cubed as our final answers for every single one of these questions. So the easiest way to think about volume is with physical blocks. So if I had one of these blocks that was 1 centimeter up, 1 centimeter across, and 1 centimeter back, it would look something like this. We would say that this would be 1 centimeter cubed. Makes sense. But then if I added a second cube like I just did there, we could see pretty easily that now instead of having 1 cube, I would have 2 cubes. And the only thing that's changed here is the length, or how far back this cube has gone. So instead of being 1 there, that's now a 2. So if we needed to explain what the volume of these 2 cubes would be, all we would have to say is that it's 2 cubic centimeters. And this continues along and along. And then if I added another row next to these ones, just like this, you could see pretty easily that I had 2 across the front, and they still go 2 rows back. So if you needed to explain how many cubic centimeters were in this shape, we know there would be 4. So having an understanding of how many are in the first row and then how many move back as we go on is really the fundamental idea that we're going to have to get on top of. And I'm going to show you how this works when we move forward into actual formulas. So before we get into the formula, we've got to understand this idea of cross sections. So a cross section is like a slice of the 3D object that shows us what it would look like in 2 dimensions. Kind of like if you had a whole stack of paper and you just took one paper out, that would be the cross section of the entire ream of paper. So this one here kind of looks like a Toblerone bar. If I was to break off one piece of Toblerone, it would be the same shape as the entire bar, and that would be the cross section. So if I made a slice just here, something like that, and took it out, this blue section would look like the front of the entire prism, which just does make a lot of sense. So the idea about a prism is that it's a 3D object that has at least one direction where the cross section is the same no matter where you took it. So in that example of the Toblerone, it doesn't matter if I made that slice at the very front or the very back, I would be getting the same triangle every single time. The reason that this is so helpful is that if we find the area of that cross section that's the same the whole way through or continuing to repeat, all we have to do is find out the area of that cross section and then multiply it by how many there are or how far back it goes. So if you're thinking about the rows, like I did in that first example, all we're working out is the area of the front and then how many rows back it goes. If you're on top of that, you're going to find this incredibly easy, and we're just going to see it in a couple of examples now. So for this first one, we've got a rectangle at the front, and then we know how far back it goes. For something like this, you could use multiple different areas because there are different cross sections that work, but I always just like to use the front. So what we've got to do is find out the area of that front rectangle. So just here, that blue bit. So pretty obviously that front rectangle is 5 multiplied by 2. And then we're saying that it goes back 8 centimeters, or there would be 8 rows of this same cross section again and again. So because it's there 8 times, I just have to multiply it by 8. So that becomes 5 times 2 times 8, which is equal to 80 centimeters cubed. That's all there is to it. As long as we've got that front area multiplied by how far back, happy days. So for this one here, the cross-sectional face is that triangle. So we just have to find the area of the triangle and multiply it by how far back it goes. The area of the triangle is 1/2 times 6 times 10. And then we can see it goes back 4 centimeters. So we just have to multiply it by 4. That just becomes 120 centimeters cubed. And that's all we've got to do for this. So for these shapes, the only important skill is really knowing how to find the area of the 2-dimensional shape and then multiplying it by the number it goes back or the number it goes up and down. So that's the only hard part. So it's pretty cruisy. So for a cylinder, we have the cross sections of the circle going all the way down. So all we've got to do is work out the area of the circle and multiply it by how far down it goes. So for this one, it would be pi times 5 squared multiplied by 12. And throwing that into my calculator would give me 300 pi. That's the most correct answer you could have. But if you need to round it to 2 decimal places, the answer is 942.48 meters cubed. And that's all we've got to do. So the actual formula that you might see is that V, or volume, is equal to area multiplied by height. Just making sure we are using that cross-sectional area that makes sense. But in my mind, this is more confusing than what the actual process of finding volume is. As long as you understand that the area of the shape repeats itself as many times as it goes back or up, that's all you've got to know. So finding that first area is really important, and then multiplying by how big or large the object is will get you the marks. Always remember to put your units as meters cubed, centimeters cubed, and you're done. Thanks so much for watching this one, guys, and I'll see you later.